proximity detectors are basically metal detectors. They are used to detect the presence or absence of metal without physically touching it. This prevents wear on the unit and gives the detector the ability to sense red-hot metals. Most proximity detectors are designed to detect ferrous metals only, but there are some units that detect all metal circuit operation. There are several methods used to make proximity detectors. Basically, the sensor coil is connected through a series resistor to an oscillator, a voltage detector. Since AC voltage is applied to this circuit, the amount of current flow is determined by the resistance of the resistor and the inductive reactance of the coil. The voltage drop across the resistor is proportional to its resistance and the amount of current flow. If ferrous metal is placed near the sensor coil, its inductance increases in value. This causes an increase in inductive reactance and a decrease in the amount of the current flow through the circuit. When the current flow through the resistor is decreased, the voltage drop across the resistor decreases also. The voltage drop in voltage can be used to turn relays or other devices on or off. This method of detecting metal does not work well for all conditions. When ferrous metal is placed near the sensor, the inductance of the coil increases. When the inductance of the coil changes, the tank circuit no longer resonates to the frequency of the oscillator. This causes the current flow around the loop to decrease significantly. The decrease of current flow through the sensor coil causes the secondary voltage to drop also. Notice that both types of circuits depend on a ferrous metal to change the inductance of a coil. If a detector is to be used to detect non-ferrous metals, some means other than changing the inductance of the coil must be used. All metal detectors operate at radio frequencies, and the balance of the tank circuit is used to keep the oscillator running. If the tank circuit becomes unbalanced, the oscillator stops operating. When a non-ferrous metal, such as aluminum, copper, or brass, is placed near the sensor coil, eddy currents are induced into the surface of the metal. The induction of eddy currents into the metal causes the circuit to become unbalanced and the oscillator to stop operating. When the oscillator stops operating, some other part of the circuit signals an output to turn on or off. Proximity detectors used to sense all types of metals will sense ferrous metals better than non-ferrous metals. A ferrous metal can be sensed at about 3 times the distance of a non-ferrous metal mounting. Some proximity detectors are made as a single unit. Other detectors use a control unit which can be installed in a relay cabinet, and a sensor which is mounted at a remote location, such as a conveyor line or assembly line, such as we use in PLC today. Regardless of the type of detector used, care and forethought should be used when mounting sensors. The sensor must be near enough to the target metal to provide a strong positive signal, but it should not be so near that there is a possibility of the sensor being hit by the metal object being detected. One advantage of the proximity detector is that no physical contact is necessary between the detector and the metal object. For the detector to sense the object, sensors should be mounted as far away from other metals as possible. This is especially true for sensors used with units designed to detect all types of metals. If the sensor is to be mounted in an area where metal shaving or other types of scrap metals exist, care should be taken to prevent the scrap metals from lodging on top or around the sensor because this can affect performance and accuracy. In the industry, use clear, shatterproof shields to protect sensors and other parts of the intricate systems. Most industrial systems today, such as for example conveyor lines, they can be a couple hundred feet long to thousands of feet long, with literally hundreds of sensors, cabinets, panels, and miles of cables. Remember, the systems should be designed to last and tested thoroughly. Capacitive proximity detectors. Although proximity detectors are generally considered to be metal detectors, there are other types that sense the presence of objects that do not contain metal of any kind. One type of these detectors operate on a change of capacitance. When an object is brought into the proximity of one of these detectors, a change of capacitance causes the detector to activate. Since capacitive proximity detectors do not depend on metal to operate, they will sense virtually any material such as wood, glass, concrete, plastic, and sheet rock. They can even be used to sense liquid levels through a sight glass. One disadvantage of capacitive proximity detectors is that they have very limited range. Most cannot sense objects over approximately 1 inch or 25 millimeters away. Many capacitive proximity detectors are being used to replace mechanical limit switches since they do not have to make contact with an object to sense its position. Most can be operated with a wide range of voltages such as 2 to 250 volts AC or 20 to 320 volts DC. Ultrasonic proximity detectors. Another type of proximity detector that does not depend on the presence of metal for operation is the ultrasonic detector. This detector operates by emitting a pulse of high-frequency sound and then detecting the echo when it bounces off an object back to the sensor. These detectors can be used to determine the distance to the object by measuring the time interval between the emission of the pulse and the return of the echo. Many ultrasonic sensors have an analog output of voltage or current, the value of which is determined by the distance to the object. This feature permits them to be used in applications where it is necessary to sense the position of an object. Things to consider when working with proximity detectors. Sometimes, depending on the manufacturer of the sensor, there will be necessary to make some target correction factors to determine the sensing distance for materials other than the standard mild steel. A correction factor is used. The composition of the target has a large effect on the sensing distance of inductive proximity sensors. If a target constructed from one of the materials it detects, the nominal sensing distance must be multiplied by the correction factor listed in the manufacturer's specifications. For example, ferrous selective sensors do not detect brass, aluminum, or copper, while non-ferrous selective sensors do not detect steel or ferrous-type stainless steels. That is all for today regarding proximity detectors, or commonly known as proximity sensors. Thank you for watching, and please like, share, and subscribe.